Imagine teaching a rock to recognize cats. Sounds impossible, right? But with artificial neural networks, we've taught machines to do just that, and more. These networks mimic how our brains process information, using layers of interconnected nodes called neurons. Each neuron makes a tiny decision, and together they solve complex problems. It's not magic, it's math, structure, and a lot of data working in harmony. At the heart of a neural network are neurons, tiny decision makers. Each one receives inputs, applies a weight to them, adds a bias, and passes the result through an activation function. Think of it like a filter. Only certain signals get through. These neurons are organized in layers, and the more layers you have, the deeper the network, hence the term deep learning. So, how does a neural network learn? It starts with random guesses. When it makes a mistake, it adjusts its internal settings, those weights and biases, using a method called backpropagation. This process is guided by a loss function, which tells the network how wrong it was. Over time, with enough data and corrections, the network gets better at making accurate predictions. Neural networks shine when dealing with patterns, like recognizing faces, understanding speech, or predicting stock prices. They don't need explicit rules. They learn from examples, show it thousands of cat photos, and it figures out what makes a cat a cat. This ability to generalize from data is what makes neural networks so powerful, and sometimes a little mysterious. But neural networks aren't perfect. They need tons of data, and they can be fooled by subtle changes. Ever heard of adversarial attacks? Slightly altering an image can trick a network into thinking a panda is a gibbon. That's because they don't truly understand. They just find patterns. It's powerful, but also fragile, which is why researchers are constantly improving them. There are many types of neural networks. Convolutional neural networks, CNNs, are great for images. Recurrent neural networks, RNNs, handle sequences like text or time series. Transformers, the latest stars, excel at language tasks. Each architecture is tailored to a specific kind of data, making neural networks incredibly versatile across industries, from healthcare to finance to entertainment. In short, artificial neural networks are the backbone of modern AI. They're not conscious, but they're incredibly good at spotting patterns and making predictions. As we feed them more data and refine their designs, they'll only get smarter. Understanding the basics is the first step to navigating the future of technology, and maybe even shaping it.